Next question we're looking at comes from Lungile. So Lungile, thank you for sending us a 3D question of trigonometry. I hope you're going to see what you needed to do to unpack this kind of a question. So maybe if there is anything you need to learn from today's program is that the 2D and 3D trig is not complicated. It's application of trigonometry. So what you need are only two things. First of all, you need to identify a triangle that has a minimum of 3 things on it. 3 things that you're already looking at. That's the first thing that you always need to keep in mind. Identify a triangle that has a minimum of 3 things that are given already. Then the second thing is, if you'll notice that you have a lot of triangles flying around in your diagram, right? So you don't matter about whatever they want you to prove. Don't matter about that. Just know this. Use that triangle to find information for other triangles by calculating the common side. You'll notice that your triangles are connected somehow by sides, right? So if this triangle has enough info, I'll use it to figure out the common side so that it's going to feed more information to the other triangle that is on another plane, right? So that's essentially what is going to happen to help you to be able to figure out the solution. So the next question, let's check it out. I already tried to draw it on the sketch here. It says here in the figure, there's a couple of things that are happening there. I have already tried to sketch them for you because we don't have time. And we are required to express AK in terms of sine x. So check this diagram here that I already have for you guys. We've got a diagram that has got a couple of points, and you will notice that on the horizontal plane, we've got this lovely triangle here, which is triangle AKF. That's the triangle that we have. On that triangle, we've got 2 angles that are given. Angle F happens to be 2x, and the angle at point A, which is the foot of a pole AT, is 90 degrees plus x. So those are the 2 angles we have in that triangle. So that triangle I just highlighted in green, which happens to be the triangle on the horizontal plane, does not have enough info because it only has 2 things. 90 degrees plus x and 2x. Even though we can work out the third angle, that is not enough, right? Now, when you go to the horizontal plane, the vertical plane, there's another triangle ATK, which I'm going to highlight in yellow, this triangle here. This is what I call the golden triangle. Why? Because it does have 3 things on it. For example, we were told that it has an angle of x at t. We were also told that the length of TK happens to be 2 units. And remember, the horizontal plane is always perpendicular to the vertical plane. So that angle there will always be 90 degrees, right? So that is going to be my first triangle of interest because it has got 1, 2, 3 things on it that I can do something on to try and figure out anything that the examiner could be interested in. Now, it turns out that the first thing that they want us to do is to express, right? They say to you, you need to express AK in terms of sine x. That's what they want us to do. Now, when we say express something in terms of something else, it means we are asking you to work out AK. So they are asking you to calculate AK, find this. But your answer must have this inside it. It must be containing sine x. It must have, on the final answer, must have sine x on it. So let's go to that triangle of interest and try to figure out what we can do to work out the length of AK. Now, if you look at that, you'll notice that that triangle there happens to be a right angle triangle. We have got that side, which is opposite the angle x. And if it's a right angle triangle, so I can use my socket saw. So that is opposite angle x. And my 2 happens to be the hypotenuse in that triangle AKT that we have. So I can just simply go and say the sine of x is the opposite side, which is AK, divided by the hypotenuse, which is equal to the value TK, right? And then from there, I'll then substitute TK because we know that we are looking for AK, and we were told that TK is actually equal to 2, so divided by 2, that is what my sine of x is. And by cross multiplication, if I put this over 1, you'll agree with me that AK is going to come out as 2 sine of x. And then that is the first solution to the first question that they wanted you to do. Not complicated at all, very straightforward. In fact, in trigonometry, they like asking the easy questions first and then the difficult questions follow after. But what you have found, what you have calculated is not for fun. We're not asking you to work out AK for no reason. We're helping you in a way to have more information for calculating future questions. And if I remove this opposite side that I wrote here, if I remove that and I replace it with the actual length that we've worked out, this is good practice. Always get into the habit of doing this when you're working with trigonometry and Euclidean geometry. After finding stuff, just write them on your diagram because they enrich some of the things that you didn't know, and then you can be able to work out the solutions for questions that follow up after that. Now, what does this do for us? The green triangle on the horizontal plane, you will now notice that that green triangle now has a lot of information on it. When we started, it only had two things. It had 2x and it had 90 degrees plus x. But if I redraw it now, what do you have? You now have 2 sine x here. You now have an angle 90 degrees here plus x. And in addition, you've got a length of, another angle of 2x here. So you now have 3 things. That means this triangle is ready to help you to figure out any of its either sides or its angles. As long as you've got 3 things, you can be able to do anything on that particular triangle. And that is what I want you to take from today's session. Right, so the next question says to us here, we need to calculate the numerical value of kf, right? They want us to find kf now. So step 1, where is this kf? Locate where this kf is. And then after finding it, you ask yourself, is it lying in a triangle that has got at least 3 things on it? Once it does, then you can apply either the cosine rule or the sine rule to figure out the length of that particular side. So let's see what we can do in this case. Now, they want us to figure out the length of that side there. They want to find kf. Okay, cool. So let me remove what I have written here and create space for us to see what we can do. All right, we'll just try and slot it here. Right. Okay, fine. So if you check that triangle, what do we have? Well, we've got an angle F there with 2x, and we've got the length of the side opposite to that as 2 sine x, right? Now, that means I can actually use the sine rule because every time I've got a side and an angle opposite to that side, then the sine rule works best because we don't have 2 sides and an included angle. If we had 2 sides and an included angle, we could use the cosine rule. So in this case, I'll have to use the sine rule. What does the sine rule say? Remember, the side opposite angle F is small f. The side opposite angle A is small a. I'm going to use only those two. I'll compare only those two. So I'll say A over the sine of angle A is as good as F over the sine of angle F, right? What is my small a? My small a is the length kf, which I'm going to represent here, divided by the sine of the angle opposite that side, which happens to be 90 degrees added with x. Now, this needs to be equated to small f. Small f is the side opposite your angle f, and we found it to be 2 sine of x. And this needs to be divided by the sine of angle f, which is given to us as exactly 2x. Right. Now, from here, the trig is done. The rest is just algebra. You might, of course, need to simplify a couple of your trig identities when you meet them, but algebra is also going to play a big role. So by cross multiplication, like I said, you can just cross multiply that part. But before we do that, let's try and simplify this side 90 degrees plus x. So this is as good as kf divided by, according to reduction formulas, when you've got 90 degrees plus x, this is going to help change sign to cosine. So this is going to change to positive cosine of x, right? Equals to 2 sine of x divided by sine 2x. Now I'm going to apply cross multiplication by just cross multiplying cos x only to where 2 sine x is currently lying. And this is going to give us kf equals 2 sine x multiplied by the cosine of x divided by the sine of 2x, right? Now, at this point, you will notice that on the denominator, we've got the double angle of sine, which we know the expansion of to be something very interesting. The expansion of sine 2x right there, according to what we know. And then this information is given to you guys on the information sheet. We can just call this 2 sine of x multiplied by the cosine of x divided by, that expands to 2 sine of x multiplied by the cosine of x. And then you'll notice that everything there is going to cancel out. So when 2 divides 2 out and sine divides sine out and cos divides cos out, somebody might say 0 is left, but no, that's wrong. Anything divided by itself will give us an answer of kf. Now that should be the solution to this question. Now, the important thing I want you to understand is the question was specific. They said find the numerical value. So if we didn't get a number, that would mean that we made a mistake, because the question that you sent was saying find the numerical value of kf, and our kf is 1, and 1 is a numerical value.